3.9 related rates, and there is a tiny leftover from 3.10. Okay, related rates. Okay, what does this mean, and what is the idea here? Imagine that we have a balloon and we pump air in the balloon. What happens when we pump air in a balloon? The radius, the surface, volume, you can say the diameter, but the diameter is twice the radius. All these change at the same time. I'm not saying they change with the same rate of change. I'm only saying that when I pump air in a balloon, radius will change, will increase, surface will increase, volume will increase. So all these become functions of time. Because the input will trigger the output. More air will trigger more radius. More air will trigger more surface area. More air will trigger the volume. It all depends on time. So radius will change with respect to time. The surface area will change with respect to time. The volume will change with respect to time. So this is number one that happens. Number two that happens, their rate of change. What there? Those functions' rate of change will be related by an equation. They will be related. They will not be just all over the place. They will have a relationship. There will be a relationship among those. Okay, so let's see how this works with a very simple situation. Okay. Yeah, so let's take a look at the following. We have two cars that start at the same point. One will travel south at a rate of 60 miles per hour. And the other one will travel west at a rate of 25 miles per hour. At what rate is the distance between the cars changing after 2 hours? So they start at the same point, and here's what happens. This is one car, and this is the other. This one obviously is faster than this one. So they start at the same point, and this is what happens. Two hours later, they may be at this distance. So this one goes slower. This one goes faster. And I'm interested to know what happens with this distance between the two. Okay. In order to know the rate of change of the distance with respect to time 2 hours later, I have to have a function. A function that depends on time. What function? Well, the function is distance. Which distance? So let's suppose that this is in a particular instant, and this will be the distance between the two. I don't want to call this d, because when I differentiate, I don't want to write dd, so I'm going to call it w. I'm going to call this x, and I'm going to call this y. Before I even continue, my first question to myself is, what is this? What does it represent? What is this? What does it represent? So what do you think 25 miles per hour represents? What is it? I need to know what this represents, and I need to know what this represents. Can anyone help? It's okay if you're wrong. Really, I promise you. What would you say? It's a rate of change. It's a rate of change of distance with respect to time. It's very clear from the measurement unit. So what is the distance in the picture? The distance covered by the first car. It's the rate of change of x with respect to time. What is 60 miles an hour then? What do I denote that by? Excellent. Perfect. I identify what I'm given. And now I need a relationship that involves W, because this is what I'm interested in. Can anyone say anything about an equation or relationship or anything that I could use to express W somehow in an equation?
dW over dt?
Equation. Yes, I agree. dW over dt is what I'm asked to find. Absolutely. When time equals 2 hours. I agree. This is the question. I was going to get to that in a minute, but you're way ahead of me, which is great. This is what I'm asked to find. But now I need an equation that has W, or some expression that has W in it. What do you think? Is there anything from this triangle that I could write? Do we remember the Pythagorean theorem? Yes? Well?
X squared plus y squared equals w squared?
Right. But please don't say x squared plus y squared equals w squared in general, right? It's
Okay.
the leg squared plus the leg squared equals the hypotenuse squared. But I fully understand, it's perfect what you just said. Excellent.
So would it just be x plus y?
Okay, let's address that. The square root of x squared plus y squared does not equal the square root of x squared plus the square root of y squared. This is never possible. You can say the square root of AB is the square root of A multiplied by the square root of B. That is allowed this under real numbers. So this is allowed, but taking the square root of a sum or a difference, never. You can never do that. Okay, so our equation is w squared equals x squared plus y squared. 3 functions of time. How do I get to determine dw over dt? What should I do to both sides that we learned in this chapter? And how is it called? It's a procedure that we need to apply to both sides. And what do I get? And how do I apply it, and what is it called? Anyone? It's called implicit differentiation. And I will differentiate the left-hand side, I will differentiate the right-hand side with respect to time. So here's what I get. 2w dw over dt equals 2x dx over dt plus 2y dy over dt. Is this clear? Do we understand what's happening here? Do we agree with this step? Good. So then we will continue. We are trying to solve for this. This is our variable. I can divide both sides by 2, and I will do that right away. In the next step, I will solve for dw over dt, dividing both sides by w. So then the next step, oops, sorry. Quiet. So dw over dt is x dx over dt plus y dy over dt divided by w. And you could say you don't have the w. That's okay, because I'm going to take the square root. So from w squared equals x squared plus y squared, I will apply the square root to both sides, but all I can write, and I should write plus or minus. Well, I would not, but I should write plus or minus the square root of x squared plus y squared, but this is a distance. So I will go back and erase the minus. Good. So now the whole thing will become dw over dt equals x dx over dt plus y dy over dt over the square root of x squared plus y squared. And of course, now I'm ready when t equals 2 hours. Okay, so let's see what we have and what we need to determine. Not a big deal. We already established that this is 25. We established that this is 60. All we have to do is determine x and y. Once I have x and y, I get the final number. So how do I determine x? We go back to the problem. X was the distance covered by the first car or the second car, it doesn't matter. The car going, was it east or west? I don't remember. I graphed it as if it was west. It doesn't matter. One travels south and the other one travels west. Yes, it was west. Good. So I need to determine this distance, and I need to determine this distance exactly after 2 hours. Can anyone tell us what is the distance covered by the first car after 2 hours?
50 miles.
Very good. Indeed, 50 miles. Awesome. Can anyone give us the distance covered by, so this is 50 squared. Distance covered by the second car in 2 hours.
120.
Yes. Assuming, of course, we are assuming that it's uniform motion and they do not stop. They do not have brakes, they do not accelerate. Yes, so that's a pretty much a pretty big assignment, a set assumption. Good. So now I'm going to write all these numbers one more time so you can see them. So 50 multiplied by 25 plus 120 multiplied by 60. Everything divided by the square root of 50 squared plus 120 squared. And let's see what we get. My calculator, right here. Don't forget to put parentheses around the numerator. So I have 50 multiplied by 25 plus 120 multiplied by 60. Close the parenthesis and divide by the square root. I like parentheses around the quantity, around the radicand. 50 squared and plus 120 squared. Close the parenthesis and press enter. 65. Without a measurement unit, this means nothing. What is the measurement unit for 65?
Miles.
It's a rate of change.
Oh, miles per hour.
Excellent. The measurement unit for the top over the measurement unit for the denominator. Because at what rate is the distance changing? Any questions on this problem? So, what happened here? Where's my first page? Right here. So, what happened was, we had, like in my simple example here, we had three functions of time, x, y, and z, and w, and their rates of change. Maybe I should write rates. So their rates of change are related. How they are related? By this relationship. This is an equation that relates three rates of change. 1, 2, 3. Okay. Any questions on this problem before we move on?